All right, so we need to talk about transformations, and when we have quadratics, quadratic functions here, each one of these numbers does things. So if we look at this problem, y equals 2x plus 1, if that turns into y equals negative 5x squared plus 1, that's going to have some changes that occur to it, right? So the very first thing we need to figure out is kind of the general form. So typically we talk about parabolas as something like this. And we'll just do the most basic one first. So if we have like 1x squared plus, let's say 0x plus 0, that's going to be a pretty plain looking parabola like that. I can change these values to kind of figure out what they do. This last value, which we typically nickname these ones A, B, and C, right? So this last value with no x, if I change that to 8, or let's say like 5, right? You can see how that controls the y-intercept. Watch if I change it to a 4 or a 2 or even something negative like a negative 1. So that's what that last value controls, the y-intercept. If I take this first one, it's a little bit more tricky to see what this one does. So I'm going to make a slider, and I'm going to just call it A, because that's the A variable. So if I slide this, so this is right now is A equals 1, the one we know. If I drag it this way, it'll make that number bigger. So this will be like 2x squared plus 0x, right? So you can see the bigger, the bigger a number is, the more narrow it becomes, right? And that's because like if I stop it right here, this is the same thing as 6x squared if a equals 6, right? This will grow as fast as x squared grows, right? Except for then you're going to multiply it by 6, right? So you can imagine, just like a line will increase slope, that number would be like will make it grow quicker. That's what that 6 does, except for it makes it grow on both sides quicker. Same thing if I put this as a really small number, like 0.1. 0.1 is a pretty small number, or let's say like, let's do a half, right? This means that it's going to grow half as fast as x squared normally would, because every single time, whatever the x squared is, you're going to immediately multiply it by half and cut down its size, right? So let's just take a look at it, and I'm just going to click play, and it's going to go through all the values. So as this, I need to put an A in front of it. So it starts at 1. So if it's a negative value, like negative 7 or something, that probably is going to open down. And if it's a positive value, it's going to open up. And the bigger it is positive, or the bigger it is smaller, the more narrow it is. So you can see as it gets to be a bigger number there. I'm going to mess around with the B value finally. And this one's a little bit trickier to see. So I'm going to create a parabola there. And a hint for this one is watch the vertex, right? There's the vertex. It's labeled. You can kind of see it kind of bounce up and down here. And basically controls where the vertex goes and the axis of symmetry. And you can see if you follow it with your finger that it forms this kind of upside down parabola shape. And we'll talk more about how we can figure out where the vertex is with that B in later lectures. Okay, so back to the problem at hand. We want to figure out what happens if I change 2x squared plus 1 into 5x squared plus 1. So we can kind of imagine right off the bat that this 2x squared plus 1, what it does basically is it shifts it up 1. Our y-intercept should be at 1. And this is 2x squared, which differs from x squared. This is 2x squared right here. If it was just x squared, it'd be a little bit wider, but it's 2x squared, so it's brought in a little bit. I'm going to turn on to this one, and you can see this is 3x squared plus 5. I'm going to change it to this. Well, here's negative 5x squared plus 1. You can see it still has the same y-intercept, except for now it has a negative in front of the a term, right, and from the x squared, which makes it open down. So that's the transformation. The y-intercept doesn't change, but this thing flips vertically and will get narrower. If you look at this problem, you can see we have negative 1x squared plus 5 versus 0.5x squared plus 15. Now 15 is going to be off my graph here. But you can kind of see both of them open down because both their a values are negative. And my y-intercept for this one's at 5 and this one's at 15. So transformation is it got lifted up 10 units, right? From having a y-intercept at 5 to having a y-intercept at 15. That's 10 units. It's still opening down, but now it got a little bit wider too because it went from 1 to a half. If this was still just negative 1, it would be a little bit thinner, right? But it's a half, so it's a little bit wider. This next question is kind of a tough one. I'm looking for a transformation that flips direction, gets narrower, moves up 3. So I'm just going to come up with a generic one like 3x plus 5. And I'm looking for an equation that will do all of those things. Right? So I'm going to focus on this part first. I need it to move up 3 units. Well, if this has a y-intercept of 5, moving up 3 units from there would be 8, right? As you can see, my blue one, right, is kind of a wide one compared to 3x squared. So this one I just came up with, right? It doesn't matter what I chose here. Really with this question, and you just have to create a baseline. Really what they want is anyone that, in relation to this equation, that will work. So I need to get narrower, so 3x squared would make it the same width. How about something like, I don't know, 170x squared. That'll really make it narrower. And I also wanted to flip, and the way I do that is by putting a negative 170 in front of it. And that's how you do those transformations.